There we go. All right, so let's get started. Today's Friday question of the week. And we're here doing pre-calculus today. Welcome. My name's Terri Grigsby. I am the owner of Tag Tutoring, as you can see there. I tutor high school math, algebra, geometry, algebra 2, pre-calculus, everything but calculus right now. So as you come on in, please say where you're from, say hi, and let us know what you're up to. Okay, so every Friday I'll be coming in, like I said. Join me every single Friday on this channel, and I'm also on YouTube under Terri Grigsby. That's my channel over there. So both places. And if you have any questions about math, please put them in the comment section. I'm going to do my best to watch comments here as best I can. And if you'd like to have me answer a question next Friday during the week, please feel free to come onto my Facebook page, put a comment in, and I'll try to hit that topic next week. So I want to make this as very useful as I can for you. So the reason I came up with this is because all week long I'm tutoring kids, and we all tend to be in the same spot in our classes for the most part. And I thought, well, why don't I do one question a week from different topics? And like I said, one week will be algebra. Last week it was algebra 2. This week's pre-calculus. And then I also do geometry. So I'll be trading off as kind of the mood inspires me in a way. So this week I'm inspired by pre-calculus. So that's what I wanted to do. So let's get started. Excuse me. Let's get started here. Let's see if I can make this green do what I want it to do. That's not the one I want. Where is the one I want? Maybe it's this one. That's the one I want. So let me come over here. I'm not on the right page. Me and buttons. This week's been all about hitting the buttons that are crazy here. So I'll be working on the whiteboard here. This is kind of like how a tutoring session would go with me. I use a whiteboard called Bit Paper. That's where I am in right now. And then I record myself on Zoom, or we see each other on Zoom. I'm not using Zoom right now. But this is basically what it would be like, you and I talking and then working on the board too. So let's talk. The questions I had this week all revolved around trigonometry. And so in the time we have, I thought I would talk to you about evaluating trig ratios if you're given a point. So look at me. It's like I came prepared to class or something, you guys. And so here's a question. They gave us the point 6, -17. And then we have to find the cosine of theta. So do not worry. These are not hard. So normally you may have to graph it, or at least you might have to figure out which quadrant it is in. But I'm giving you the quadrant. What I want to do is from this point now, I'm going to build myself a rectangle. And I'm going to build a right triangle, a rectangle. Oh my gosh, you guys. How about I build a triangle? Oh my gosh. And it will be a right triangle. And so theta here, that will be theta. It's a little squishy. And now they give me the point 6, -17. And you just have to keep this straight. Remember, every ordered pair is x, y. So the 6 would go right there along the x-axis. The y would be -17. That makes sense because we're in quadrant 4, right? The y should be negative. And then for us to do this, now we're going to need to know the hypotenuse. So let me get a little triangle going here. It won't necessarily, let's see, I don't know. There we go. Let me try that again, you guys. I don't know what's going on today. There we go. Look at me go. Okay, so I'm going to just make it bigger. So there's theta. This is 6. This is -17. And I need to find the hypotenuse over here. So how are we going to do that? Good old Pythagorean theorem. So I would go a squared plus b squared equals c squared. And all you have to remember is that the two sides along the 90-degree have to go together. The hypotenuse goes by itself. So I'm going to go 6 squared plus -17 squared equals c squared. So 6 squared is 36. 17 squared, I want to say is, let me see, I don't know what it is. I don't know. I was going to say 289, and then I thought, no, that's not right. 289 equals c squared, so that will give us 325. I'm going to double check that, see how trusting I am on a Friday afternoon. I don't know how trusting I am. So I'm going to check to make sure I added correctly. Look at me go. 325 equals c squared. Take the square root of both sides. And then I'm going to simplify this because probably in your pre-cal class, you're going to have to do that. So I don't know what 325 is. I'm just going to break it down as 5 times 65 and 5 times 13. So it looks like C comes out to be 5 square root of 13. Okay, so that's your first mission. You got to find all 3 sides of the triangle. Then it really doesn't matter which trig ratio they ask for. You're going to be able to find all of them. So, but for this case, I'm doing cosine. And remember, cosine is adjacent over hypotenuse. And how do I remember that? I remember that because of SOHCAHTOA. So a kind of been reformed on SOHCAHTOA. That's just an acronym to remember it. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. But when I was teaching in the classroom, I used to call it COSOLTOA. Why? Because it was fun to say like that. That's all. COSOLTOA. I don't know, but I know everyone in the real world says SOHCAHTOA. So we're going to do cosine. I digress. Look, I was crazy in my classroom. I did things to entertain them, but I did things to entertain myself, and COSOLTOA was one of those. So adjacent side on the triangle, that would be adjacent. Negative 17 would be opposite, right? So the side that makes up the angle, the other side that makes up the angle is the adjacent, right? So we're going to go 6 over 5 root 13. But you're not done yet because you can't leave a square root on the bottom of a fraction. So we got to rationalize it. And to do that, you're going to go square root of 13 over square root of 13. And that's going to give me 6 square root of 13 over 65, right? Ugly little number, but hey, we're in pre-cal. We can do it, right? All right. I don't know that anybody's joined me. I'm going to look real quick in the other. I'm going to pull up a tab and look just to see if anybody's in there. I saw a few eyeballs on us, so I wanted to just check and see if anybody had said anything on my live, if I can find it quickly here. Here we go. So nobody's in there yet, but if you are watching, I'd love to know where you're watching from. The 3 of you that are still here. Hey, I'll take 3 people. Let's keep going, though. Esme's here. Hey, Esme. By the way, you need to hire Esme. She's awesome. I'll put her up here so you can see it, and it's not just me. Here's Esme. Look, isn't she beautiful with her husband? She is from Dallas. And Esme, remind me what you tutor again. I think it is Spanish, but it could be reading, and I don't remember, Esme. Can you pop in real quick and tell us? And I'll leave you up there for a little bit so people can write your name down and so they can hire you as a tutor also. I don't know. She might have popped in and popped out again. I wouldn't blame her. Audrey. Audrey's here also. Audrey, I know what Audrey does. Audrey is a super good math online tutor. Much like myself, we both do high school. And she's also a coach for online tutors. She's pretty cool, dude. And then Esme said she does reading. See, I have Esme. Come on. Did I not get it right or what? I not only nailed the Spanish, but you also do reading in English too. Reading in English and Spanish. So there's 2 more tutors if you like them. You need to go hire them right away. Okay, so let's get back to what we're doing here. So I'm going to go on to the next problem. They kind of all work like this, but we'll just see how it goes here. So I'm going to see if maybe I can make this bigger. Oh, I can. Good, because I need more room than I got myself last time. So again, now we're doing cosecant, but now we're over in the 3rd quadrant. So I'm going to bring this bad boy up here and make myself that right triangle. And the angle, the theta, is always the one at the origin. That's where theta goes for all the trig stuff. Okay. So now we have -2 up here and -3 here. And so Pythagorean theorem again. So -2 squared plus -3 squared equals c squared. So that gives me 4 plus 9 equals c squared. So c squared is 13. And then c would be square root of 13. Okay. So if I'm doing cosecant, you guys, that's not part of Casaltova. Okay, look at me. Now I'm just having fun naming the acronym. And I know it's backwards, but once you hear a Casaltova, you'll never go back to SOHCAHTOA again, unless you have to. All right, so cosine, sine, and tangent, that's not cosecant. There's no cosecant there. And so what you have to remember is what the reciprocal functions are. So the reciprocal function to cosine is secant. And the reciprocal function to sine is cosecant, if I can spell. And the reciprocal function to tangent is cotangent. And so reciprocal, obviously, we're just talking about flipping it. So for secant, if cosine is adjacent over hypotenuse, secant is hypotenuse over adjacent. If sine is opposite over hypotenuse, cosecant then is hypotenuse over opposite. Tangent's opposite over adjacent. Cotangent is, wait for it, I can hear you shouting it. I don't know, maybe I could. Is adjacent over opposite. So we're looking at cosecant. So we're going to do h over o. And that would give us square root of 13 over, now opposite to that angle, opposites over here, adjacents here. So it'd be over -3. And boom, just like that, you're done. So as soon as you've built the triangle, you've got all you need to find any trig function that you want. Okay. Let me see. Let me go back. Let's see. I'm just looking to see if we have any other comments here in the group. Okay, so let's keep going. We're just going to keep practicing a couple of these. This one I picked only because it had a nasty square root of 17, and that sort of intrigued me. Because you can't scare me with your math. No, you can't. You can try to put funky numbers there, but you know what? I'm going to solve you anyway. Huh, take that. Honestly, I'll be honest. When I'm doing math, I honestly believe I can do anything. Like, I go into it very optimistic, believing I can do any math that you give in front of me, no matter how hard it is. And I know that sounds weird, but my students, when I was in the classroom, and even my people I tutor now, they'll go, okay, well, you think anything's fun, so they'll find me these killer problems. What they don't know, the ones that I have now, is that if you give me a really hard problem, I will not rest until I get it figured out, including not going to sleep at night until I can get it figured out. My people that I taught when I was in high school, when I was teaching high school, they knew that, so they would do that to drive me crazy. And I wouldn't have been surprised if a couple of them gave it to me just to dissuade me from writing a test that we're going to have that week or the next day, thinking I'm going to put Grigsby up with this problem. She won't have any time to write it because it'll take her all night to figure it out. But I always had my test prepared anyway, so ha, joke's on you guys. All right, here we are. We're back at cosecant again. So here we go. Notice they're showing the angle going from the 0 position right here to going back to that blue terminal side. So obviously when they show you that, they're telling you you have a negative angle. All you pre-cal people. Now that is not going to affect what we're doing because we're not finding angles, we're finding the ratio of the sides. That's what sine, cosine, tangent, cosecant, secant, cotangent do. They just figure out the ratio of the sides. And then, of course, if you have a ratio of a side, you can blow up the triangle really huge, and the ratio has to stay the same, or you can make it even smaller, and the ratio has to stay the same. So the angle doesn't bother us when we're trying to figure out trig ratios. Okay, so I got a -8 here and a square root of 17 here. And good old Pythagorean theorem. You can't stop me. I ain't afraid no Pythagorean theorem. Probably shouldn't talk like that, but hey, trigonometry makes me happy. which is interesting because when I was a student, the hardest subject I ever learned for math was trigonometry. Yeah, somehow my little Pee Wee Terry brain, and when I was in the 11th grade, couldn't really handle trigonometry that well. And I had this blessed, wonderfully, hugely patient teacher called Mrs. Selman. And she worked with me every night after school because, like I said, I don't give up easily. But that poor woman went through the ringers trying to teach me trigonometry. So kind of a special place in my heart. Calculus wasn't hard to me. It was trigonometry that killed me. I don't know why. All right, so we digress. Square root of 17 squared would be 17, right? And 64? Well, that doesn't seem that hard now. As soon as you put it in Pythagorean theorem, you will get rid of the square root. So that will give me 81. Oh, that's nice, people. That's a 9. Niner. All right, so cosecant is the reciprocal of sine. Another way to write reciprocals is like this. 1 over cosecant like this to show that they're reciprocals of each other. So technically you could find the sine, just to show you a difference here. I could find the sine. Let's see, this is opposite hypotenuse and adjacent, right? So sine would be opposite over hypotenuse. That would give me square root of 17 over 9. And then I could just do the flippity-doo-dah. I could just flip it and then know that I would get 9 over square root of 17. You really don't need to do that here if you've got all 3 sides of your triangle, but just for future reference. So I'm at 9 over square root of 17. I've got to rationalize that. So match it. Square root of 17 over square root of 17. So that gives me 9 square root of 17 over over 17. Now, the question of the century, is this next move legal? Boom! So it must be 9. What do you think about that, people? So let's think. How can 9 over square root of 17 equal 9? How, in the name of all that's right in this world, could those two be the same? How could you divide the number by square root of 17 and have that equal the number? No, you cannot do this. However, if I had $1 for every time one of my students tried that maneuver, I'd be a rich woman. I'd be a very, very rich woman after teaching for 33 years, I think, or so now. So the answer has to say 9 square root of 17 over 17. I used to say, and I still say, I actually use that this week. I would say that's mathematically illegal. And the kid that I said that to, his parents were both lawyers. Well, I'm going to take that up with my parents. I'm like, fine. If they know how to simplify these radicals, let's have a discussion about that. But he knew I was kidding. I'm assuming the no was for me canceling, Audrey. I know, but I know you've seen it too, girl. You've seen it. All right, let's keep going. Let me see. Okay. So here we go. It doesn't really change. I only picked this one because it even had a nastier square root on it. So I thought, why not? But once you get the hang of these are really quite easy. So there's the 90. Again, another negative angle, right? And this is theta. So we've got, what, -4, and we've got 2 root 5 over here. So I'm going to do Pythagorean theorem again. So -4 squared plus 2 root 5 squared equals c squared. Now, the other mistake I always see, oh, if I had a dime for every time I saw this one, I don't even need $1. If I had a dime for every time someone punched that in their calculator and got -16, I too would be a rich woman, just on dimes alone. No, just because your calculator tells you that's the answer doesn't mean the calculator is right. You must be smarter than your machines. That's all I'm saying. So that doesn't equal -16. That's ridiculous. Okay, so -4 squared is -4 times -4. How about 16? Because we know whenever you square a number, it comes out positive. Okay, over here, I'm going to be a little bit careful. This means 2 root 5 times 2 root 5, correct? So I'm going to multiply the outside numbers together. 2 times 2 gives me 4. Square root of 5 times square root of 5 gives me 5. And so that will give me 20. That's why I really grabbed this problem. Okay, c squared. Look, it's coming out beautifully again. This is going to be 36. Take the square root of 36. And so c equals 6. That's beautiful. I love when you go through like all these crazy hard, this isn't that hard, but crazy math problems, and you have to show all this work. You have to go this way. You have to go that way. And then it comes out to be this beautiful whole number. Like, it's like magic. I was doing that today this week with trig identities. I love giving kids trig identities where where you're simplifying a trig expression and it comes out to be 1. So they go through pages of trying to simplify this thing, and when they're all done, it's 1. I know, but that's beautiful to me. And I must admit, this is a little evil of me, but I think I need to admit it now. Hi, my name is Terri Grigsby, and I may or may not have written a test in my life for a pre-calculus class, simplifying trig expressions, where every trig expression simplified to 1. Guilty. I'm guilty because it was too much fun. I know that's evil because you're working it and you think, no, they can't all be 1. That can't possibly be right. But in my defense, it was not a test. And in my defense, it was very enjoyable for me. But again, in my defense, it was not a test. It was a little quiz, just messing with them. And then we talked about how you should just do the problem and get the answer you think the answer is, and not try to think about what I think the answer is. If you think I wouldn't write a whole test with 1s, well, now you know I would write a whole quiz with 1s in it. And so you just have to know your math, and then you'll be better prepared. And you know what? They were better prepared because of that. I have other stories, but I'll stop with that. So let's go back to our problem. We're doing sine of theta, so that is opposite over hypotenuse. So in our problem, opposite's over here, adjacent's -4, hypotenuse is 6. So that'd be 2 root 5 over 6. And then don't stop there because you can simplify the 2 and the 6. Now that kind of simplifying is okay because they're both outside the radical, right? So that will give you square root of 5 over 3. And that would be your answer for that one. Okay. Let's see. Do we have other comments? Audrey's laughing. I appreciate it. You can feel my pain. Kathy, you meanie. I am a meanie. Okay, I'm a meanie. Guilty. Okay, then because you called me meanie, I must tell you another thing I did. Hi, my name is Terri Grigsby. I teach math, and I may or may not have written an entire multiple choice exam where all the answers were A. Guilty. I know, but here's why I did that one. That wasn't me being cruel. Well, it was a little cruel. Okay, it might have been a lot cruel, but here's why I did it. My class where I was teaching in a private school, LaSalle people, anyone here from LaSalle in my area? I taught at LaSalle Catholic School for about 6 years, and all the kids were coming in. Well, this other math teacher gives multiple choice tests. Well, this other math teacher gives multiple choice tests. Why don't you give multiple choice tests? And they knew darn well when they told me that I didn't like multiple choice tests because then you don't have to show any work and you can guess at answers. And to this day, I don't like that. And so they kept hounding me, and they knew I had a sense of humor, and then they could keep hounding me and I wouldn't like kill them or anything. And so they kept hounding me, and I said to myself, okay, the next test, I'm writing a multiple choice test because they want one, but I'm making all the answers A. Guilty. So that was cool because you just know every answer is not going to be A. And by the way, it was not the same class that I made the quiz where all the answers were 1. And I only did those 2 things in my whole 33-year teaching career. So, I mean, twice, right? That's not so bad. Okay, it's a little bit bad. I only say it's a little bit bad because the student that I told that to this week thought I was evil. True evil. Like, do I look like true evil? I may look like evil, but do I look like true evil? I don't know. I don't think so. All right, I think that is the end of our, oh no, we got one more. Let's do one more. And again, we're going to do the same thing. Let me make it bigger first. See, you're getting all these extra stories. Only because it kind of makes me laugh. I don't know. I know that's wrong, but I also know that I would live and die to help those kids conquer their math no matter what it took. And you'd be surprised all the things I used to do to help those kids through the tests. I'd let them retest. I would work with them one-on-one whenever, including weekends. So while that's a little evil, I would do anything to help those kids. And to this day, help my kids learn the math. There's just no way around it. So, okay, so down here, we got a 4 here and a 2 root 5 over there. And we need to find the hypotenuse. So I guess 2 root 5 squared isn't going to be a mystery today on this one. So that came out to be 20, right? Plus 16 equals c squared. I sense a theme. 36. See, I could have made every answer be 6. I shouldn't be dreaming up other ways to be evil, but I don't really give tests anymore, so I can be evil now. All right, tangent is now opposite over adjacent, right? And so that would give me, let's see, this would be opposite. Let's put theta in. Opposite and adjacent. So I'm going to get 2 root 5, excuse me, over 4. And again, we got to reduce it. Take the 2 out of both, so I'll get square root of 5 over 2. A perfectly beautiful number. So it's not so hard. The steps: make a triangle, find all 3 sides with Pythagorean theorem, and then plug into the trig identity, whatever it is, and then make sure you simplify. Make sure if there's a radical on the bottom, you just simplify it. So there's that. Let me go back in, see if there's anything else. Okay. I know I'm getting a lot of comments about how evil I am, but that's okay. You can laugh. You can laugh. I can be evil. I can be evil. Most people that know me don't think of me as evil, though. There's got to be perks for teaching, though, right, kids? I'm just kidding. That really was not a perk. It's just, and to my defense, I would never have done that if I thought the kids couldn't handle it, and I knew they could. Okay, I'll give you my last one, and then we're going to call it a day here today. My last thing I did, this also was at LaSalle. I don't know what happened at LaSalle. They were college prep. I knew that they needed to be pushed extra hard. So I was teaching AP Calculus, and I trained my kids to not look around during a test. No, you do not look around. I don't care if you're sleepy or you want to stretch. You better stretch with your eyes on your paper, because I don't want to see any eyeballs moving left and right and up and down. And so I trained them that way all year. And so they were taking their final. And as they got up to leave, I pointed to the back board in my room, which is very large. And on it was sitting all the solutions to all the problems on the final. Not just answers. I wrote out exactly how to do it step by step by step by step. But because I had them trained never to look around, nobody in that room saw it until they left. Well, I know, right? But here's, again, to my defense, this is why I did it. Because you know when you have high-powered kids in a class, they just want to know, did I get it right? Did I get it right? And I would spend like days, did I get this one right? Did I get this one right? So I just point, and then they could see if they got it right or not. So I was actually saving time by doing that. There was a lot of this going on as they left. Oh, you got to have a sense of humor. If you're going to have me for a teacher, that's all that they had to learn. And again, like I said, I really did care about them, and I always wanted them to do well. And so we're going to stop here on this one. Let me get back to just me. Thank you for all your comments, everybody. Before we go, though, I want to remind everybody again to join me every Friday at 1 p.m. right here, Pacific time. And we'll do some more math problems, talk about more teacher stories. I've got a million of them, frankly. And if you'd like to know more about me, maybe hire me for a tutor. I still have openings right now. Please do. My website is tagtutoring.com. Why is it called Tag Tutoring? Terri Ann Grigsby is my name. But I used to kid my kids. Tag, I used to say, they used to call me Tag. They used to call me a Tag student. You go, why? So talented and gifted. And then every student I ever said that to laughed in my face, which I thought was cruel. I said, okay, maybe it was Terri Ann Grigsby instead of talented and gifted. No one ever accused me of being talented and gifted. So That's why I called myself Tag Tutoring. And look me up there. Also, if you saw this video and you found it useful, and you know other parents that might find this useful, please feel free to share this video with other people. I'd love for them to see it as well. And again, I'll be back here Friday. If you have any questions from your kids that they may want to jump in and get some extra help on, have them just put it in the comments of this video. And next week we can talk about it. How's that? Okay, I'm going to let everybody go for now. Thanks for joining me. This has been fun. Me and Trig. I love Trig now. I'll see everybody next Friday. Bye-bye now.